Yeah, now see here, what is that we are doing now? Here, how to calculate? See, we know what is B0, and then we are going with the we have to find out what is the equation for electric field. So what is that? Now here, what is E0? See, the formula for C is equal to E0 by B0, implies what is E0? E0 is equal to C into B0. E0 equal to C is 3 into 10 to the power of 8. What is B0? B0 value is 2 into 10 to the power of minus 7. We got 60 volt per meter. Now what you have to write? Ez equal to what? E0 into sine of 2 pi x by lambda plus 2 pi t by small capital T. This is the equation. So Ez equal to how much? 60 into sine of 0.5 into 10 to the power of minus 3 into x plus 1.5 into 10 to the power of 11 t volt per meter. This is the way we write the equation for electric wave. Is it clear, all of you? Is it clear? Yes. Okay. Now I am going ahead with the next one. That is what this Hertz experiment. This is removed from the syllabus. Hertz first he confirmed experimentally the existence of electromagnetic wave in 1880. In 1888, he demonstrated experimentally the existence of electromagnetic wave. But now we are not doing this. This is removed. Removed from the syllabus. Just remember this one. What is the frequency of electromagnetic wave? This can be calculated by mu is equal to 1 by 2 pi under root of LC. Okay, we can find out the frequency of electromagnetic wave using this formula. Nu is equal to what? Nu is equal to 1 by 2 pi under root of LC, where L is the inductance value and C is the capacitance value. L is the inductance value and C is the capacitance value. Okay. Now next one. So we'll go with the parts of electromagnetic spectrum. How is the electromagnetic spectrum divided? Electromagnetic wave spectrum. How it is? Electromagnetic wave spectrum is so how it is divided here? See, this is visible region. Okay. This is visible region. This is infrared IR region. Then microwave. Then we have radio waves. This is the order in which wavelength. Okay, this is the wavelength, increase of wavelength. Okay, in which it is increasing. Here we have ultraviolet, then we have X-rays, then we have gamma rays. Okay, that means frequency is the frequency is less here, the frequency is more. There is a difference. Okay, here frequency is high, frequency is low. Wavelength is high, wavelength is low. Okay, so this is about the. So we will start with the radio. So he started from here. So what are the parameters what we are going to discuss? We will discuss about the frequency. We will discuss about the wavelength. We will discuss about the source. How do we produce this electromagnetic waves of that particular wave? Then source, then detectors, Then after that we will discuss the uses. Okay, source, then detector, then uses. Okay, these are the parameters what we are going to, suppose if there is any hazard from this also, that also we are going to discuss. Okay, any hazards, that also we are going to discuss now. So what is that now? These are electromagnetic waves of frequency range. What is the frequency range? 5 into 10 to the power of 5 hertz to 10 to the power of 9 hertz. That's the frequency. And these waves are produced. How are they? How are they produced? These waves are produced by oscillating electric circuits having an inductor and capacitor. Okay. So how are radio waves produced? They are produced by electromagnetic waves of frequency range from 5 into 10 to the power of 5 hertz to 10 to the power of 9 hertz. And they are produced by oscillating electric circuits having inductor and capacitor circuit. Okay. So that circuit has a inductor and capacitor. Same like here. That is the reason how the electromagnetic wave is produced. So what are the uses? So that is how the frequency is given to you, the production is given to you. You know how to produce it. Detectors, they are detected by the antennas. Okay, these are detected by the antennas. And what are there are as of now there are no hazards. Only uses. What are the uses? So electromagnetic waves of frequency range from 530 kilohertz to 1710 kilohertz, that is known as amplitude modulation. In radio, in your car there is a radio. That radio has AM and FM. So we have AM 530 to 1710, and then it is generally used as ground wave propagation. Electromagnetic wave of frequency 1710 kilohertz to 54 megahertz. They are known as short wave bands. So they are used as in skywave propagation. Skywave means like for you can understand for this, for radar signals. Electromagnetic waves of frequency 54 to 890 megahertz are used in television waves, TV. For TV we use. Electromagnetic waves are 88 to 108. They are used in FM radio. FM radio, the commercial FM radio. What the radio we use? Okay. How much it is? 88 megahertz to 108 megahertz. So it is used for commercial FM radio. Next is electromagnetic waves of frequency range 300 megahertz to 3000 megahertz. Form ultra high frequency band. It is used in cellular phone communication. So you might have seen that. What is that? This is 88 to 108. 88 to 108. That is normal radio. Like we have 88.8 FM, then 89.1 FM, 102.6 FM, 106.1 FM. These are all the commercial radio. The next one is electromagnetic waves of frequency range, how much? 300 to 3000. They are said to be ultra high frequency. They are used in cellular phone communication. What is the meaning of cellular phone communication? You might have seen this Jurassic Park. I think second part, I think, where this man will the actor, they go to the Greenland or somewhere to get their children. So they will use a cellular phone. The cellular phone is can be directly connected to the satellite. The cellular phone is nothing but a satellite phone. Okay. So, one second. Now see here, cellular phone communication. These are the uses. Okay, first we started with the production. How did we produce? We need a LC circuit. Inductor capacitor means LC circuit we need. With LC circuit we produce electromagnetic waves, and this is the frequency is given here. And next is what? These are the uses. They have ranges actually. There's a different range for different wave bands. For AM 530 to 1710 kilohertz, that is for ground wave propagation what we use. The second one is 1710 to 54 megahertz that is skywave propagation. That is also known as shortwave propagation, shortwave band, SW band we say. This is other name. In the old one, they have given SW band. The electromagnetic waves of frequency range 54 megahertz to 890 megahertz are used in television waves. Okay. Next is electromagnetic waves of frequency range 88 megahertz to 110 that is 108 megahertz form frequency modulation. Okay, so it is used for commercial FM radio. And the last one is for cellular phone communication. We use this. Next comes the second one. The second one is microwaves. Okay, microwaves. They are how are they produced? Microwave frequency is from 10 to the power of 9 hertz to 3 into 10 to the power of 11 hertz. This is the frequency of microwaves, and they are produced using special vacuum tubes called klystron or magnetrons and gun diodes. This is the way how we produce microwaves: klystron, magnetron, and gun diodes. This is klystron is in your microwave oven. If you open the microwave, there is a lamp, there's a tube like thing, a small lamp, like a fuse, if you see the fuse, like small tube thing, like that, a little bigger, not that so small, it is a bigger tube. It's the same way. That is klystron diode. Okay, microwaves are used in radar system for aircraft navigation. Okay, and also microwave ovens are used for cooking purpose. And a radar using microwave can help in detecting the speed of cricket ball, automobiles, and aircraft in motion. Okay, so you already know the uses. So again, as of now, we haven't discussed about the hazards of microwave. They are saying that there are some hazards, but how does one should know how the mechanism? How does a microwave cooks the food? Means if you keep the food inside and it becomes warm, it becomes hot. How it is happening? Actually, there is a moisture in the food or the water molecules in the food. When you keep this food in the microwave oven, so what it does is it will the molecules will oscillate with the frequency of the microwave. Then because of the vibrations, they oscillate. Those oscillations or vibrations are converted into, when they converted into heat energy, mechanical energy is converted to heat energy. So that is how the food is being uh, cooked. So, and better not never use the plastic vessels. Okay, it's not good. And whenever you're using, use porcelain vessels, so that will be safe. So they will say they are like plastic vessels are also microwave safe, but it is, as of now, I don't think so it is safe. Now, infrared waves. Next, infrared waves were discovered by Herschel, uh, the name of a chocolate company also the same. Okay, Herschel. So Hershey's we say, this is a Herschel. So these are electromagnetic waves of frequency range 3 into 10 to the power 11 hertz to 4 into 10 to the power 14 hertz. Infrared waves sometimes are also called heat waves because their absorption causes the heat effect in the bodies and surrounding. Suppose if you are standing very close to a hot vessel, even you can feel the heat. How it is traveling? These waves are heat waves. These waves are also known as infrared waves. Infrared waves are produced by hot bodies and molecules. These molecules are not detected by human eye, but snakes can detect. Insects can detect these infrared waves. Okay, insects can detect the infrared waves. Next is, infrared waves are used where? In physiotherapy. You know the physiotherapy. Suppose if there is any muscular strain or any sprain in the body, then we use this physical therapy. So when you go to physiotherapy, they will connect the electrodes and the infrared waves are given to the portion of the body. So it will relax, your muscles will relax. To provide electrical energy to satellite by using solar cells. Okay, so how do we produce? So it has to, so satellite is not having any energy, it has to produce its own energy. So we have solar cells. So the sunlight is having electromagnetic waves, visible radiation, as well as infrared radiation. All these, this is in infrared waves are taken in and converted to electrical energy. In greenhouse gases, or in greenhouse, to keep plants warm and for producing dehydrated foods. Like we have greenhouse, greenhouses means like there will be a net, something like that, and very big dome thing they make it. Okay, then in that, they keep the plants, and the plants are warm using, because they want to trap the infrared waves to produce the fruits. For taking photograph during the condition of fog and smoke, for that purpose also we use this. And especially in the dark photography, especially the NGC, National Geographic Channel, they study about the movement of the creatures in dark. So they have a photography, they cannot put light, and by the, if you put light, then all this will run away. So they take the photography in the night. So they use a IR photography, what we say. In solar water heaters and cookers also we use this. In checking the purity of chemicals in the study of molecular structure. As I told you when I was teaching you atomic physics, like every atom, in atomic physics, every atom is having a spectrum. So for that we study, okay, IR spectrum. We have IR spectrum, UV spectrum, visible spectrum. So there also we are using this IR infrared waves. Okay, is it clear? Are you okay with the first, second, and third? Means radio waves, microwaves, and infrared waves. Are you clear with this concept? Yes, sir. Are you clear with the first, second, and third? Radio waves, microwaves, and and infrared waves. Are you clear with these three? See what you have to discuss. We are discussing the frequency, then wavelength you can calculate. Just remember any one. One is enough to remember. If you can remember the frequency, then you can use C is equal to nu lambda. From there you can calculate the wavelength also. How to calculate wavelength? 3 into 10 to the power of 8 divided by frequency. Just substitute, you will get the wavelength also. So don't remember it. Remember only for the frequency. That will be sufficient to find out the wavelength. If you are able to remember, that is okay. Otherwise, not required. Any doubt? Yeah, is it clear up to here? Yes, sir. Okay. Yes, Mr. Sayyam and John. Is it clear? Okay, okay. I didn't know that. Let me check my email. Okay, if it is there, then let me check. I'll because I'll get the email from. One second. Okay. No idea. Maybe we'll check. Okay. Okay. So, okay, I'm going with the visible light. It's a narrow region. Like visible region is very narrow region of electromagnetic spectrum, which is detected by human eye. Its frequency ranges from 4 into 10 to the power of 14 hertz to 8 into 10 to the power of 14 hertz. It is produced due to the atomic excitation. The visible light emitted or reflected from objects around us provides the information about the world surrounding us. So, like whatever you want to see, it should be, first of all, you should have visible light. Then only you will be able to see the object. Okay, you will be able to see the object, or you will be able to see the see the object, or the you can take the photos, photography, and all. Next is electromagnetic, UV rays. What are UV rays? They are discovered by Ritter. The frequency is how much? 8 into 10 to the power of 14 hertz to 3 into 10 to the power of 16 hertz. We are going toward the higher frequency from the lower frequency end. The ultraviolet rays are produced by sun. Okay, they are coming from the sun. Also, we can get from special lamps and very hot bodies like sun, stars. Okay, they can produce ultraviolet rays. Most of the ultraviolet rays coming from the sun are absorbed by the ozone layer in the Earth atmosphere. So, see, the sun rays are having all the three: ultraviolet, infrared, and visible. But out of that, the ozone layer is trapping. They get trapped or filtered by ozone layer. They are not reaching the Earth. If it was reaching, then everyone would have skin burns, skin tanning, skin cancer. All these issues used to be there. But thanks to ozone layer, which is protecting us from the harmful rays. The ultraviolet rays in large quantity produce harmful effect on human eye. It's not good for. So never look at the sun with the bare eye, the naked eye. Okay, never look at the sun directly. It's not okay. In the morning and evening, that is a different thing. Like before 7 a.m. or after that after evening, like that is okay. When the sun is at the horizon, it's okay. But otherwise, never look at the sun directly. It can cause blindness. Okay, so they are very harmful. Ultraviolet rays are used for checking mineral samples through the property of UV spectroscopy. So, what is that fluorescence phenomena? As Henry Becquerel was doing this experiment, fluorescence phenomena, delayed photoelectric effect. Hope you remember that when I was teaching the discovery of radioactive uh, waves. I was discussing this at that time. I have explained this one also. What was that? I was telling you about this one. Yeah. Now, now he says about what? See, he tells about the. So the ultraviolet rays are produced by what? The ultraviolet rays are produced by, yeah, yeah, ultraviolet rays are coming from the sun, and ultraviolet rays are used in UV spectroscopy, that is in fluorescence phenomena, in the study of molecular structure and arrangement of electrons in the external shell through UV absorption spectra to destroy the bacteria for sterilizing of mm, for sterilizing the surgical instruments. Let me explain this. Now, to destroy bacteria means in water after purification, like we take the seawater, we have a desalination plant here in all the Emirates, like especially in all the except I don't think so. It is in available in Ajwan and all. So they have desalination plants. In India also we have desalination plants in Chennai. So that is this. So the cost of desalination plant is around 100 crores Indian rupees. Means they convert the salt water to drinkable or usable drinking water. Okay, so that is what they do is once the water is purified, they expose to the sunlight. So if any bacteria is in the water, it can be killed. The second one is in sterilizing the surgical instruments. Like suppose the blades or the forceps or the scissors, what we use for surgery. So even though they clean with the Dettol and all, it may have some bacteria. So they are kept in the UV or gamma ray, uh, that one. So they are exposed to the sunlight so that the bacteria gets killed. So next one is what in the detection of forged documents, like suppose for a forged note, that is duplicate notes or duplicate stamp papers. In that also we use this fingerprints in forensic laboratory and burglar alarm. Okay, so fingerprints in forensic, like suppose if anyone is has stolen something, so they take the fingerprints with that. We detect using the UV spectroscopy. Next is X-rays. Next one is X-rays. The X-rays are produced by what? By whom? This was discovered by great scientist W. Röntgen. So what happens this is the gun, when the fast moving electron it goes and hits the that is the tungsten Pg. Then what happens? Electromagnetic waves are hard. That is hard one. Then what will happen? And these are produced when high electric energy are stopped suddenly on a metal of high atomic number. X-rays have high penetrating power. Okay, these X-rays have very high penetrating power. So there are hazards. So what are the hazards of ultraviolet rays? They can cause skin burns, they can cause skin tanning, they can cause skin cancer. Keep that in the mind. So and also X-rays are also very dangerous. So here we have to discuss the hazards also now, apart from the uses. For ultraviolet, X-rays and gamma rays, we need to discuss all the hazards also. Now, the frequency is given here. Then when a fast moving electron is stopped with the high melting the metal, then what happens? Electromagnetic X-rays are produced. Now, X-rays are used in surgery for detection of fractures. Like we have, so now what happened? Foreign bodies like bullets, diseased organs and stones in the human body, like for kidney stones, and if there are any and fractures or foreign objects like bullets and all that can be detected using X-rays. We have soft X-rays and hard X-rays. Okay, soft X-rays are used for in medical sciences. Hard X-rays for faults in cracks in the metals and all. We use that in radiotherapy to cure untraceable skin disease and malignant growth. Okay, that is radiotherapy. Even yeah, for that purpose we use. In detective department for detection of gold, silver, and explosives in the body of smuggler. At the airports or when you cross these airports or immigration and even in expo, everywhere they use this. Uh, you know, uh, they use X-rays to detect the gold, silver, explosives in the bag. In industry for detection of defects in rubber tires, gold and tennis ball. Suppose if there is any crack inside the tire or gold gap, like sometimes it will look like a bangle, but inside nothing is there. Outside it will look like a bangle, like hollow. So that can be detected using the or cracks in the metals using the X-rays. Uh, and in scientific research for investigation of crystal structures, in chemistry, we have Frankel defect, Schottky defect, and all. This also can be studied using X-rays. Arrangement of atoms, molecules in the complex substances. Okay, like Buckminster fullerenes and diamond, graphite, and all the structures we use this one. Last one is gamma rays. Gamma rays, the frequency is 3 into 10 to the power of 18 hertz to 3 into 10 to the power of 22 hertz. And gamma rays have nuclear origin. They are coming from the nucleus of the radioactive element. They are not coming from outside of the like from the it's not from the electron. It's some reactions are happening inside the nucleus, and then rays are coming out. They are said to be electromagnetic waves. So highly energetic and produced by nucleus of radioactive. They are generally coming out from a radioactive substance. They are very harmful also. What is that? Gamma rays are used in the treatment of cancer, chemotherapy. Used to preserve the foodstuff for a long time, as the gamma rays can kill microorganism easily. Means it doesn't allow the fungus to form on the food. To produce nuclear reactions, like again nuclear reactions we have fission reaction, fusion reactions, and again in fission we have you know uh, the controlled nuclear reaction, uncontrolled nuclear reaction. In controlled nuclear reaction we have, in controlled nuclear reaction atom sorry controlled nuclear reaction example is uh, nuclear reactor, and uncontrolled chain nuclear reaction example is atom bomb. So you know that recently the Chernobyl nuclear power plant was captured by Russia. So well, this is one of the biggest power plants, nuclear power plants. Okay, to provide valuable information about the structure of the atomic nucleus. So for that purpose we use. Okay, so this is about the this is all the uses, sources, detectors, uses, and hazards. So they are not good. Gamma rays are not good. So they can cause cancer, but they are also used for treatment of cancer. So gamma rays and X-rays are very not good. Generally, even the pregnant ladies, even though for pregnant ladies we go with ultrasound, we never go with X-rays. Actually, if they have any defect, also never ever the ladies, that is the pregnant ladies, are given these X-rays, because they are very harmful. They can go for abnormal growth of the baby, or they can create an malfunction in the cell formation. So for that reason, or some improper growth can take place in the baby's body. So for that reason, in the fetus, for that reason, we never give X-rays to the pregnant ladies. Okay, so even gamma rays are also very dangerous. They also can cause cancer. Okay, X-rays and gamma rays can cause cancer. So if you, unless and until you require, never take a X-ray. Never go with X-rays. X-rays are very harmful. Okay, if they are okay for once or twice, it's okay. But otherwise, no need to take X-rays. Okay, X-rays and gamma rays are very harmful harmful for human body. Now, next one you have seen the gamma rays. Now next starts the the numericals. So you might have seen. So these are some of the questions related to our topic. Okay. So yeah, the first question says, name the electromagnetic wave which maintains the earth warmness. And what is that? Infrared waves. They are infrared waves, not the UV. UV means ultraviolet. Maintains earth warm is heat waves. He speaks about the heat waves. That is IR rays used in aircraft navigation. In aircraft navigation, we use microwaves. Even in the mobile phone waves, we use microwaves. Why is small ozone layer on the top of the stratosphere crucial for human survival? Because it protects us from the harmful electromagnetic waves. It filters electromagnetic waves. Next, third one. In electromagnetic wave, the oscillating electric field having a frequency is given, amplitude is given in the positive x direction. What is the wavelength of electromagnetic wave? Write down the expression to represent the